Alright, this is an explanation to mock paper 2, set 4. And please pay particular attention to question number 39. Okay, so here we go. Now in this question here, we talk about the locus of a fixed point and a line. So F is a fixed point, and that the line L. So the locus of that, when we have a fixed point, normally it's like a curve or a circle. So by looking at this, what we can do is to eliminate some of the possible options. So we see that being a curve, then option B, D are unlikely. But if you look again in C, if you choose any distance from the point here, if I say this point here is of P dash, then obviously the distance between the line and P dash and the fixed point F are not equidistant. So C, that will be out of the consideration. So the only possible answer here is A. So if I have a P dash point there, the distance between F and P dash and the line L, that look possibly be the same. So the possible locus of P would be A. In these questions, talk about different type of data. So talk about discrete data. Now discrete data we normally refer to as countable. So countable, the type of number that goes with it are normally integers or like whole numbers. So the other type then will be continuous data, where there are always an outcome or values lies between two possible values. So these will be continuously. So we refer to those as continuous data. So in this case, for discrete, we refer to them as countable, like 1, 2, 3, and 4, and so forth. Height won't be countable because it's continuous. And this is also true for temperature as well. So therefore, number of students is countable. And the answer here is A. Now in this question, we have two values, 1 and another one is A. So we know the standard deviation is 4, and that we want to find the mean. So the mean of the two numbers will be 1 plus A divided by 2. So let's start by looking at the definition for both standard deviation and the mean. So we now have the standard deviation, and here's the mean. So the variance then, we square both sides and put the value in 1 and A. And as for the mean, actually we know that the mean is actually sum of x divided by 2. So 2 times the mean will be the sum of x. In this case, the sum of x, there are only two data, and that is 1 and A. So A is actually 2 mu minus 1. So by putting in the numbers and substituting A as 2 mu minus 1, we now can work out another expression in relevant to the variance. Now at this point, what we can do is to either make the first term 1 minus mu to be the same as the second term mu minus 1 by taking a minus 1, or we could make the second term the same as the first. So all I want to do is to make the first term same as the second one. Okay, so let's see how it's go. So take out the minus 1, put a big bracket, all square. So now, if we follow through, what we can see is that the mu minus 1 all square times by 2 is equal to 2 times 16. So very quickly, we could work out the algebra. So we square root both sides, and then we get 4. So mu is 5. But what I suggest you can do is to try to break this up. Okay, so at this point, you try to break this up and make that into 1 minus mu. Okay, by taking a minus 1 here, and then make it all square. And see if this here gets you a different value. And remember here, you need to check the value that you're looking for is going to be positive. So try it yourself. Now in this question, we need to find out the number of possible roots. So we could examine each of these. So A, so the tan is sine over cosine. So hence then, we see that there's only one possible value. But where's the other? Note that sine of x minus 2 equals 0. But then, sine cannot be bigger than 1, so we reject that. And hence, we end up with just two possible values for the x in this case. And as for c, so we could factorize c. And then we can solve, put it equal to 0. So actually, x is 45 degrees, where sine of x equal to cosine of x. As for the second expression, we see that it ends up with tan x equal to 2. So x is possible in the first quadrant and possibly in the third quadrant. So in here we have three possible values of x. And as for d, we square both sides, the cosine, the square root of that plus or minus 1, and hence we get two possible values. So the most number of roots actually is of c. Now in this last question here, we have two circles, a small circle with center B and a bigger circle with center A. And the radius of circle with center A is 3, and the radius of the small circle with center B is 1. So we fill in the information, and given that the angle of ABD is 150, therefore we could find the angle of ABF. So put in information here. This angle now is of 60 degrees. So what we're going to do now is to examine each of the condition. But first, let's look at the condition of 2, where it says BDCF is a square. So looking at the triangle of AFB and the angle here, we could work out the side. So I'm going to let AB be A. You can actually work A out actually. A is actually 2. So I now have f of A is equal to 3A over root 2. Now as for f of B, and that turns out to be A over root 2. And obviously they are not the same. So hence, if they're not the same, then option 2 is out of consideration. And because in this here there's only B without option 2, so hence the answer here is B. So thank you for watching. If you've got any questions, please come and find me. Okay, so bye for now.